So because I jumped up and I gave my my only joke for the night away in answering that question about the engineer thing, I don't have much to say now. Our next speaker is another Culture Trip employee. He's a recent hire. We actually joined on the same day. If we hadn't joined on the same day, he would have been one of the reasons that I joined Culture Trip. So he founded and was CTO of, so another ex-engineer, founded and was CTO of a couple of successful startups before. But hands up, who's got a Stack Overflow account? Wow, less than I thought. Jeff. So Jeff joined us from Stack Overflow. He was Chief Operating Officer. He joined as employee number something like 7 or something crazy like that, and really built that company, worked with their data, worked with their sales teams, and built it into what it is. And he's going to, there's going to be a conversation later on tonight between Dave and Jeff about the contrast between these two talks.
Almost there.
Sorry, do you want me to?
No, it's okay. Well, we're just about there, I think. Ooh, look at that. Perfect. Hey, everybody. As Roger said, Chief Operating Officer of Culture Trip, just on the job now for a little over a month. Prior to that, where's the pointer? There we go. Prior to that, spent a number of years at Stack Overflow, really one of the people behind the scenes, building the business behind it. I think the number of people that I saw in terms of raising hands is about right in terms of actually having an account on Stack Overflow. It's something like 5 to 10% of programmers having accounts. I think the number is right. And I'm assuming most people, if you develop, are at least familiar with Stack Overflow. Anyway, that's kind of in the past. So maybe we'll change gears here a little bit from talking about Culture Trip and ourselves a little bit to a little bit more geeky or technical topic, I guess, in terms of interest to engineers. This talk here is, I apologize in advance, it's sort of a shortened form of something we could probably spend all day talking about. In the interest of time, this is just intended to be a little bit provocative to kind of maybe start a conversation, poke at a few things that are sort of maybe conventional wisdom or not in various areas of developing. So again, me, Jeff Szczepanski, Tall Jeff is kind of that's my handle on Stack Overflow. Has been since the day the site launched. Actually, I was a user of the site. Any case, again, Chief Operating Officer now at Culture Trip. So what are we really talking about here in terms of this Agile Waterfall Continuum? That's sort of the catchy name for the talk. Maybe if I was a professional consultant, they'd trademark that and say, we're going to go consult about the Agile Waterfall Continuum. But it's really a talk here about technical debt or minimizing technical debt. And so we got to start from the point of defining that, actually, and what do people think of as technical debt. Won't go through all the different things that we would normally think of here around, like schedule slips happening, non-predictable schedules, bug fixes for your bug fixes, all the kind of things we think of as code that's sort of hard to maintain or make changes to is sort of a primary form of technical debt. But this talk is really about a different form of technical debt. And I'll claim there's really 2 fundamental classes of technical debt. That's the type of technical debt that was on the previous slide, which is all the things about code construction or difficulty of making modifications to the code itself, more at the programmer level. But the other kind of technical debt that's actually the more insidious kind in a lot of ways from the standpoint of trying to build a code base that scales with your business and can be built with not only supporting the scaling team, but a scaling success in the marketplace, and where you really get traction and the types of things that tend to go wrong with code. And this gets into this idea that as you evolve your application from earlier phases, there's an accumulating kind of technical debt as you go from version 1 to version 2 to version 3, where how much code's getting tossed away? How much sort of system-level refactoring is it? What's a marketing feature that somebody says that we need to do for customer reasons? It's actually really hard to do with your code base, or it's hard to bring in. It's not that you can't change the code. It's that the abstractions in the code base don't match up well so much with the new feature that you're trying to add, and there's a lot of pain to go back and refactor things. And so when we're looking at how much of that is actually unavoidable. And I see things in a lot of teams and a lot of different companies. I spend a lot of my time, spare time, I guess you could say, advising different startups in different phases and all kinds of different forms. And through my career, founded a couple of different companies and all my time at Stack. And then now is work with different startups in their various stages of scaling. And you will see that people sort of claim that they're running into these unavoidable things that could not have been foreseen based on where they started in version 1.0 and where they are in version 3.0. And I'm going to claim that that's, in some ways, can be avoided through some basic techniques or thinking around things of how you actually approach the code. And I'm not going to answer all those questions today, but again, it's really about sort of planting the seed about some norms that we see in the industry and how things are thought about in modern terms, and maybe some older techniques or thinking that could actually help address these kind of problems, especially as you scale as a team, in an organization, and a product. So this other definition of technical debt, I'm going to claim a more formal definition. It's basically this notion of a misalignment between what's easy to do with your code and where you're trying to take the code base and what it needs to do from a business perspective. When it starts to be expensive features or hard things to do with your code base, that's a whole different type of technical debt that you're trying to avoid. And I think if you're a CTO or senior person in engineering, one of your actual goals of maintaining the asset of the code base that's being used for business purposes is to actually minimize the gap between what's easy to do from a market need standpoint and what's easy to do with your code. And if those things are diverging, you sort of have a technical platform problem of sorts. And lots of different companies get caught in this very explicit ways when there's big platform shifts. Maybe, I guess the most crazy case would be like Windows and Microsoft, right? And then all of a sudden everything goes mobile. That's a massive disconnect between what your code base can do and what you could do maybe in mobile. Sort of an extreme example, but it gives you a general idea of all of a sudden something that became important in the marketplace is perhaps hard to do with your code base. So when we look at this, there's a thing I kind of talk about this phenomenon that I think most companies go through is what I call the hot coals of scaling. Your team is where you got features and functionality here in your code base that you would like to be increasing linear with time from the point of view of your customers. How consistent can we be in doing that? So this form of technical debt basically means that you run into these hot coals areas. And the question would be is, if we wanted to think about this in different ways, what might we want to do to minimize that? And I'm going to claim, actually tied into this, is this notion that we see this strategically with product platforms of the notion of that we do development that's sort of customer compelled, doing what our customers are asking versus sort of market focused. And so I'm going to claim that the debt comes from just being customer compelled in feature development, but customer compelled in the notion of how your applications are being built. And so what does it mean to get more strategically and market focused in the code base itself? And what do those abstractions within the code need to match up to that are actually going to stand the test of time much better maybe than when we're taking a very incremental approach to solving these problems? And in effect, what do we do to ensure this? And this, most importantly, laser pointer working? There it goes. Looking at features and whole product quality in terms of that gap between what you would really like to do and how quickly can we move towards stuff that is important in the marketplace versus in the eyes of your customers versus what, in effect, is easy to do with the code or not. So I'm going to claim that the key to scaling your applications, the sort of tweetable soundbite maybe here, is that your whole goal is to actually figure out how to bring your customers and their data within your application set along with you on the roadmap, basically, the technical roadmap. You got to keep those things aligned and bring the gap as smoothly, or bring that along as smoothly as possible without the hot coals effects occurring. So that's sort of the foundation about why we're talking about this. So let's talk about software process a little bit. We'll go with an easy question maybe to start off with. Everyone agrees, right? Agile good? Waterfall bad? Hands? Okay, yes. Thank you, Dave. I knew you would raise your hand. Sorry, folks. So interestingly enough, good properties of Agile. Admits that requirements evolve. Encourages regular releases. Which allows validation of progress more often. Good properties. Sprints are excellent for driving cadence. This is something I like to talk about a lot, the pace at which you're moving your team. What sets the pace that you get this continuous forward movement. The notion of sprints within Agile and stuff is very important here. Retrospectives, love the concept. What can we learn from what we've done? How do we close the loop on things to some extent? All good properties of Agile. Pitfalls of Agile. Anybody want to volunteer any? scheduling beyond a few sprints or any kind of longer range planning that's actually predictable in time seems fairly rare in most Agile teams. Implicitly encourages feature-centric thinking. This is exactly what the backlog's all about in developing features. We think in terms of features, which is really the output at the end of all of the technical platform stuff. And this typically comes, in many cases without lots of discipline, that is what I'm alluding to, comes at the expense of good system design. And we sort of take refactoring as a given because we are driving features in incremental steps. In a sense, those are causing shortcuts of various kinds. Lighter specs, lighter documentation, all very common in very agile, focused, fast-moving teams. So this undertone, I would claim, in Agile has this notion that why plan or document things too much because it's going to change anyway. And we're going to attack this in pieces. And we're going to figure this out incrementally. Waterfall, good properties. Formal specifications rule. In other words, we do a lot of thinking about what it is that we really want to build and why. Emphasizes detailed planning, which means we can think about predictable outcomes. System design in Waterfall is specifically a thing because you have a bunch of requirements and a specification that gets developed. We can actually go off and design a system in a very structured way. Highly efficient if requirements are solid. I'll argue there's no more efficient way to develop something if you knew exactly what it was at the beginning you were trying to build. Pitfalls of Waterfall. This is why it gets a bad name. Requirements are never perfect. Encourages long serial release cycles, which makes it harder to close that loop. Spec everything, design everything, build everything, test everything, right? This whole sort of notion that you could go through in this order, and what Agile acknowledges is that that perfect cycle can't be followed. And then problems, this is probably the biggest expensive waterfall, whether it's a requirements problem, a specification problem, anywhere in the cycle, a testing thing even. Problems get discovered very late in waterfall, which makes them very expensive. So cost or errors are high, as I just said. But the observation here that I find extremely interesting when you look at this is that all the advantages or pitfalls of Agile are pretty much the strengths of Waterfall. And the strengths of Agile are pretty much the pitfalls of Waterfall. So these are really kind of two sides of the same coin in a lot of ways. And neither one of them is perfect. They tend to favor one thing versus the other, which gets us to the Agile Waterfall Continuum idea that I talk about. You really, I'm going to argue, have to think about the way we approach software process and how we manage teams and build and design systems. There's really a dial that we're trying to set that needs to be in different positions based on where you are in the life cycle of your platform, product, and understanding. And in a sense, I'm going to claim that most systems, project solutions are going to start off a bit more agile when there's a complete free-for-all of understanding requirements, customer needs, how you're going to implement something. But as you progress over time, you need to start tending towards systems and processes that get more waterfall in nature, especially when you think of roadmap technology investments, things like that. And maybe the most specific example I come, it's actually a good Facebook reference where Facebook always talked about early a very agile, move fast and break things type process. At some point in the life cycle of that company, all they did is break things. And they really became to a screeching halt and had to really implement a bunch more discipline that starts to get a lot more structured in nature that are some of the processes that you would typically think of or associate a little bit more with waterfall. Doesn't mean you can't have a lot of these agile things going in over there, but the idea is to think about this as a layered thing from systems level thinking up higher that are much more strong, more strategically planned and structured over much longer life cycles than stuff that's going down at a lower level in terms of iterating at the feature, point release level, if you'll say, or even in continuous deployment, the stuff you're going to be pushing regularly. But the system planning and the architecture of stuff has to bring to it more sort of waterfall properties, I'm going to claim. Or you will certainly need to do that to some extent as you scale to much larger teams, much more successful products when Facebook can't go down, those kinds of things, or maybe even depending on the application. That didn't come out so great here, but I have this little sketch I'd like to use to maybe put this in a little bit more real terms of like what it might mean to really turn this dial in a sense. And so on these axes here, I'm sorry if you can't read it there, especially in the back, but basically this vertical axis is about pure waterfall at one end and pure agile at the other end. super agile, super waterfall intensity there. And you'll see I say danger, crocodiles and alligators up here. If you're pure waterfall, you're going to be kind of screwed, right? At the other end of the scale, danger, crocodiles and alligators, I'm going to claim. If you get super agile, unless it's a very straightforward, simple kind of system, you're going to struggle at some point in terms of this, especially the second form of technical debt that I talk about. And so if you look at this, this is the sort of axis here. The other way is simple systems, smaller, simpler products, smaller code bases, much more complex systems, stuff where airplanes crash or people die or whatever, maybe sort of on this axis over here where the cost of errors has to be extremely low, and more structured sort of processes to every step of everything you're doing in terms of pushing code or making changes to releases. So if you look at this graph then, what we have is if we got the waterfall at the top and agile at the bottom, complex systems here on the right, simple systems on the left, you can see that maybe pure agile and complex systems, I'm going to claim, put you in Refactorville and Bug City kind of thing. And then the other extreme is pure waterfall and really simple systems. And this is what Joel Spolsky used to call the architecture astronaut sort of way of thinking about it. He wrote a whole blog post about this. And so that you're sort of unnecessarily overstructured and trying to be too waterfall-y, right? And so the most interesting quadrants in the diagram I'm going to claim are in the top right and the lower left here in terms of stable small teams on simpler projects you can maintain over the life cycle of the entire code base as you're scaling closer in the agile direction. Things like, I know this is a little bit older example now, but access development over here, these platforms that are relatively straightforward, simple applications that allow fast iteration, and there's not a significant amount of system complexity in there. And then over here, you're going to be much more waterfall-y in nature from earlier on if you're doing like embedded systems development and things that can't really fail even early on. And I'm going to claim is in most applications, as you get to much larger teams, talking hundreds or thousands of engineers on teams or millions of users or super high uptime qualities, avoiding the fail whale kinds of things maybe in some structured ways, a la Twitter, stable large team development is going to be over here, somewhere balanced between, depending how complex you are and how big the team is, somewhere in this waterfall continuum in the middle, especially over time. And so that's what we're kind of really getting at with this. And so if we were to think about this in terms of how we organize teams and what kinds of things we're doing, what are the real variables we have to sort of move us around on this set of axes in terms of what we're doing? What do we take for granted in certain standards? And I think the length of our release cycles and what those sprint times look like and what we're trying to accomplish with them is a definite variable that we have at play. In other words, 1 week sprints or 1 month sprints or 1 quarter sprints or release cycles, depending on which layer of the sort of development timelines we're talking, is definitely a variable at play that is something that can be tuned and will be different on some of your teams already. Maybe we just don't think about why it's different on certain teams quite yet. What's your clarity and confidence in customer requirements? If you really know for early on exactly what you're going to build, you can much easier waterfall and structured process things out by comparison. So where are we in the life cycle of understanding product market fit, the needs of our users, those kinds of things. Again, this showed up kind of explicitly on the graph, the depth of system complexity, like how advanced and complicated is this thing we're trying to build? What is going to be the life cycle of the test and the iteration within that to achieve something that's functional at that level of complexity? Maybe the space shuttle software code base comes to mind where in the early days it was like going back 250,000 lines of code. I don't think to this day there was ever a bug discovered in it. And that was through a bunch of formal processes around things. And a relatively complex system, certainly for when it was designed. How catastrophic are defects? That ties into the same thing. If a defect gets out in the field, is it just a little blip on some web page in my Facebook feed, or does an airplane crash? And then, of course, the size of the team and the code and the customer base. How much stuff's under management? How much stuff are we trying to maintain? If these are bigger systems and millions of copies, you better have a pretty good roadmap of maybe Apple comes to mind in this kind of thing. I'm always amazed at anything Apple does these days, right? Because they ship millions of phones. This is hardware and software complexities that no one's ever seen. I mean, well beyond even what Microsoft was doing at the peak of the Windows sort of platform. When something like Face ID comes out, and the fact that that just basically works for everybody, and that there's almost little to no bugs in that, right? Like those kinds of things start treating how strategically something like the deployment of Face ID has to be within the roadmap for years to really achieve that and be successful at it in the field right from the get-go. So tied into this is just something that comes up a lot. I'm kind of throwing this in there as a slide relative to schedules, which I think in a lot of Agile teams is the ones that I get exposed to anyway. The notion of having formalized schedules for things is really hard to come by beyond any sort of a few sprints out, as I alluded to before. But the thing is schedules are really important because when we're working with sales, marketing, customers, these people all care when things ship, right? If we have an iPhone cycle that's going every, not necessarily the best example, but every year or 2 times on a cycle, the fact that that's going to be at a fall in a trade show that's 11 months away, we need to hit that date. Something needs to be ready to ship. And they only have a few weeks probably, even with the manufacturing line and all the hardware stuff, of tolerance for that stuff being. So how do we plan in well ahead exactly what we can put in that? And you see teams obviously compromising around that. Some things don't end up in iOS 11 and they end up in 11.1 and 0.2 because they have that flexibility to do certain things like that within their life cycles, but other types of things don't. And your company may actually depend on that. Good roadmap decisions, I'm going to claim, to actually depend on very valid cost-benefit trade-offs. Going to invest in something, how long it's going to take versus doing something else that might have a certain benefit, it's actually really important. If I have a bad estimate on how long a feature is going to be and what we thought it was going to take, the joke at Stack was always, oh, that's going to take 6 to 8 weeks, which is how long Stack originally took to develop. Supposedly, the first release that went public of Stack Overflow, it actually took like 4 months or 5 months or something. So the joke was always 6 to 8 weeks, but like if you think something's going to take 6 to 8 weeks and actually take 5 months, you probably would choose to do certain things in different orders. So those things depend on schedules. But here's actually the most important thing, I think, around schedules. Other than the fact that we're pushing frequently, which will show up in Agile, schedules will actually close the loop because the predictability, the ability of the team to forecast how long something's going to take, I'm going to claim as a direct reflection of the quality of the code base. And if you think about code, how do we know, other than just sort of testing quality into things, and it seems to pass a certain set of tests, that we actually have a low amount of the first form of technical debt in the code base and that we've really built a reliable, robust system? I'm going to claim that the single best thing you can do to really verify quality, other than the testing and shipping stuff and put it in the hands of your users or exposing users to the functionality, is that if you have a team that can reliably predict schedules well in advance, that's actually a sign that we all know what we're doing and that we have a good handle on all of the processes and skills and elements that go into quality software development. If you're weak on any one of the vectors of things that are important for software development, you're going to have a hard time predicting how long it takes. And so if you really want a scalable, sustainable team that is nimble as you continue to grow the code base in a team, I'm going to claim that schedules is going to be the single best tool you have to helping you understand and close the loop on quality. So to get that quality, a lot of different skills come into play, and being explicit about what these skills are and how you're trying to develop and maintain them becomes a super important part of some of these factors that are at play that are adding noise to your ability to forecast, predict, and stuff like that. So this whole notion of discovering, developing, and finalizing requirements, a very specific skill set that you're trying to develop in people on the teams. Architecting things, designing and code construction, how code is written, all really important elements of skills you're trying to develop. Quality control, including your testing and validation. How are we approaching these things? Different types of skills that are coming into how we're writing code, what we're doing to test it. These are all things that need to be instilled in the team. Estimation itself is, of course, a part of schedule estimation and part of the teams, especially when you're trying to use that as a tool for quality. And then maintenance, bug fixes, how does that stuff work? How skilled are people at chasing down a bug and troubleshooting a problem that showed up either in, on a test platform or somehow in the field with the users. And then team morale and the things that drive cadence, another really important thing. How do we maintain smooth, continuous development rather than sort of death march kinds of things where you tend to get output pushed to make some deadline because we don't have good predictability and we still needed to meet some goal, but then there's the inevitable depression that occurs afterwards. No one shows up for a while and everybody's tired. You get this very spiky thing. So maintaining a smooth cadence and keeping people motivated and performing consistently at these quality levels, more in the management aspect of engineering and software development, but equally important to maintain across the team in a uniform way. And so for me, when I think about this from a structural standpoint of the teams, these don't necessarily have to be separate people per se. So maybe functions might be a better word here. But there's really kind of 3 key roles that I think of on the team that we're all going to be kind of familiar with. But I want to put them in a context of maybe how they play into some of these factors. And that we're trying to be more explicit and clear in how we plan things and think about what we're doing on the team through these roles. We obviously have the developers on the team as a main role. People are actually contributing code as their primary function, or one of their primary functions, implementing stuff. So you have the developers, obviously. And then there's a notion I call, different people will call this different things in different teams, but I want to highlight the notion of a team lead on there, which in most cases is going to be a player on the team. They're probably developing code and have some responsibility for some technical area or sort of function separate from product management. But I'm going to claim that a key role of the team leads actually is helping, sometimes I call these anchors on teams. Who's the anchor of the team? Who's making sure that we're moving along at a consistent way? This might be in this Scrum stuff, who's in the various roles of driving the cadence for the sprints. But identifying a specific person, there's this function or notion that you have somebody controlling cadence and trying to maintain cadence. And so that's another key function of what you're trying to do in the stabilizing a scalable team. And then finally, you have what I would call the engineering managers. And their sole function, I'm going to claim, or the majority of their function, other than sort of maybe career development of people in sort of the line manager function, which is usually there, what I'm going to argue is that you really want to have them or somebody like them in this role of skills development. So out of all those things I listed on the slide in terms of different skills, it's really the engineering manager that are tasked with assessing, measuring, and leveling people up on the team in a consistent way to those skills, but is not really worried necessarily about cadence unless they also happen to be performing a team lead-like function within that sort of matrix of things. And so the way I like to talk about this in the roles then is that if you kind of help stand it, and I apologize, this is actually an American reference here. I'm a New Yorker, now in London for a while. So they're like in NASCAR racing or any kind of race car racing. I think of the team leaders as the track racing pit crew. In the context of us moving in a continuous way, developing code, your team leads are really the ones that are keeping the car on the track and moving around at a certain speed, trying to maximize near-term performance. While I think of the engineering management as more of the garage mechanics, overhauling the engine and the suspension of the car, and really looking at the longer-term horizon of the people and their ability to develop those skills. And ultimately, working together to set up the systems and processes with all of those variables that I talked about, tuning for the different complexities and everything that kind of move you along in the 2 different axes, fundamentally, of the Agile Waterfall Continuum that I talked about. And so then if you bring this all together, what are we really trying to do? It's about minimizing technical debt, and I'm going to claim that that's really about matching your code base to the market and what the marketplace needs, and keeping that gap low so that what is important to your business is actually easy to accomplish with your code in a continuously smooth, improving fashion over time. Saying that predictability is a high correlation to quality, and anything you can do to try to put a closed loop around longer-term predictability of outcome is something that's generally going to tend to leading you towards improved quality. And that's maybe the best measure of absolute quality of the code base, is that we can accomplish the things according to the first bullet here in a very predictable manner. There's a whole other notion that I don't quite get to here in this version of it, but this idea that performance and results are actually separate, and that just because you achieve a certain outcome, it doesn't necessarily mean your team is performing well. So if we sort of get lucky and get through accomplish or maybe do a death march, and we say, hey, the result's great, we shipped on time, but what was really the performance of the team in accomplishing that? If we were to think of this in a European football reference in terms of the World Cup right now, you can win a game but not have done all that well, or lose and maybe played a really good game, just something sort of, random sort of occurred last second or whatever in the game to lose it. And so this idea that those 2 things aren't the same, and that you're actually seeking in your product development and development of the code base of not only saying that we're hitting all the checkboxes and meeting the requirements and passing the test vectors and doing all this stuff, what's really going on from the performance of the team. And again, this gets back to the quality factor and how things correlate to quality, that closing those loops and really understanding that you're after continuous smooth performance, not just certain results along the way to measure yourself again, is actually really core to doing this well over the long haul. And then this idea, I think one of the most important ones from a management and leading a team perspective is that you really do want to separate out the notion to work on performance of how people are doing skills-wise versus what's the rate at which we're moving the team forward and actually pushing code. But those are separate sort of axes, and that you want to work on them as separable things, even though I think a lot of teams tend to conflate the two. Are we on schedule, or did we do what we expected in this sprint? And is that about skills development, or is it about, well, we just didn't show up as regularly because we were tired after the last sprint or something like that, right? So this idea that you want to maintain the cadence and the smooth output independent and monitoring of the skills development. And then, really, ultimately, I think of everything as looking for long-term efficiency. And the goal here overall is leadership on teams trying to build a scalable code base and scalable product through technology is really ultimately about putting, looking at that list of all the skills that I talked about and making sure that that's instilled all of them. And then we can bring that together in a smooth way through the cadence techniques to really maintain a successful long-term product there. Thank you. Questions, anybody?
I think we're kind of short of time, so we'll just
say
just
a minute
two.
Haven't a lot of the organisations that this sort of industry looks up to spent quite a lot of years now breaking things down into smaller, more manageable chunks so that you can still be agile? And taking is there an argument to say that, the idea of this is too complex or too complicated, so you must use Waterfall, disagrees with the idea of this is too complex or too complicated, so you must get better at doing microservices so you can run distributed systems effectively and not have the cost of change being so high?
Right, I think that's a good trend, and that's specific maybe to certain types of applications, maybe like in web development or certain types of back-end services. Yeah, I think so. There was a question I remember from Sun Microsystems in the early days, and they were building the new Solaris version, and they were like, how do you manage a software development project of 10,000 people? Kind of question, I forget the exact number, it was a few thousand people. And they said, well, we don't. We have, instead of 2,000 people on a team, we have 100 projects of 20 people, whatever the math is there, right? That kind of thing. You get it down to much smaller groups, and you're developing. So that's clearly a play, and I definitely agree with that. Like anything you can do to remove the service, but I'm going to claim too that when a lot of different services start interacting, you potentially start to have unintended side effects occurring, right? Where you get a different type of complexity shows up in your system, right? So yes, absolutely, encapsulation, modularization of things all leads to good architecture, but maybe like what are all those microservices? How do they come together to do something useful? How do I know that that combination of microservices that I'm investing in over the long haul is actually going to turn into something that directly morphs into being, has the low second form of technical debt to service the next feature, right? If I have to go do something and change 17 services, maybe that's actually bad and harder than having the right combination of 3 other bigger ones that were planned a little bit more waterfall-y. Good question.
Thanks, enjoyed the talk. In terms of like practical day-to-day things that an engineering manager would do to sort of affect skills development, what kinds of practical things can people in that role do?
For relative to skill development? Yeah, so what are we doing to sort of evaluate where people are at, right? So for me, the biggest tool gets back to schedule, right? So the canary is the fact that maybe somebody who's estimating something or commits to something for a certain sprint doesn't actually achieve it. That's the first red flag, right? So then we got to start breaking it down. Did they just estimate poorly, or did they not really break the problem down into something that was sort of conceivable? And yeah, so again, this is going to depend on the level of abstraction we got, but like code reviews, key thing, right? Like, so who are they being mentored by? What do we determine the output? Do we have coding standards? How do we document what's being built? How much did the problem get broken down into pieces? I think you have these various things to start working with that individual to start, sometimes I crudely put this as how long is each person's leash on the team, right? Like, when there was major systems kind of stuff being worked, we had, like in my Allworks days, session initiation protocol, the whole backplane that's around making phone calls on a VoIP phone system. So we had one lead engineer that was in charge of that entire subsystem, basically, right? He was somebody on the team that had an incredible amount of latitude. He would, hey, Jeff, okay, we're going to do this next version of functionality on top of the SIP stack. it'll be done in 3 months. And I knew that was an incredibly reliable thing and didn't really have to have a conversation. Other people are going to talk about some simpler thing they're going to try to get done in a week. And they kind of seem to keep missing that, right? So we just need to break it down. And so that variable, the leash, I think of putting people on is the main thing you want to change. And so how far do we break them down? What high level or low level of abstraction are we working with them on? Time, probably?
That was it. No, we said 2 because of timing. Sorry.
Yep. Okay.
Thanks,
Thank you,
Jeff.
everybody. Yeah, appreciate it.